Sociotechnical systems blend technology with human society, focusing on how they interact and shape each other. They are complex networks where information technology influences human behavior, and in turn, human behavior affects technological development. An understanding of sociotechnical systems reveals how technology impacts work, communication, environmental sustainability, and even personal identity. The design of these systems can greatly affect their success or failure in meeting human needs, as well as how they support or undermine shared environmental goals. A specific example of a socio-technical system is the electronic medical records, or EMR, system used in healthcare. EMR systems combine digital technology for storing and accessing patient information with the social practices of healthcare providers and patients. The technical components include databases, interfaces, and security protocols, while the social components involve changing workflows for doctors and nurses, new patient interactions, and evolving privacy expectations. When implemented without considering how healthcare professionals actually work, EMR systems can increase burnout by adding documentation burdens that interfere with patient care. Conversely, when designed with input from all stakeholders, these systems can improve coordination between specialists, reduce medication errors, and give patients greater access to their health information. This example shows how the successful functioning of technology depends not just on its technical performance, but on how well it aligns with human needs and social practices. Sociotechnical systems are closely linked with green computing, which seeks to reduce the ecological footprint of IT systems. They also connect to discussions on digital ethics, as these systems raise questions about privacy, data security, and consent. Another closely connected idea is the circular economy, which emphasizes extending the lifespan of resources, reducing waste generation, and supporting sustainable lifestyles. This highlights the importance of integrating technology with social systems in ways that respect and enhance the planet's health while meeting human needs. From a social and biological perspective, wildlife conservation tracking systems demonstrate how socio-technical systems shape human-nature relationships. These systems combine GPS collars, camera traps, and environmental sensors with community engagement, indigenous knowledge, and conservation policies. In places like Namibia, local communities work with conservationists using digital tracking tools to monitor endangered rhinoceros populations. The technology provides data on animal movements and potential poaching threats, while community rangers contribute traditional ecological knowledge about animal behavior patterns. This integration has reduced poaching while creating economic opportunities through ecotourism. However, these systems can also reinforce power imbalances if local communities aren't given meaningful decision-making authority over the data collected or conservation strategies developed. This example illustrates how socio-technical systems must carefully balance scientific knowledge with community values and practices to create ecological benefits that support both wildlife and human well-being. The intersection of socio-technical systems with environmental priorities is seen in ideas like urban agriculture, fair trade networks, and community-supported agriculture programs. For example, urban agriculture transforms unused urban spaces into productive green areas, bringing food production closer to where people live, thereby reducing the environmental costs of transport. Fair trade networks ensure that producers, particularly those in less developed regions, get fair prices while promoting sustainable farming practices. Community-supported agriculture reduces the distance between consumers and foods by creating direct links between farmers and urban residents, which can foster sustainable local economies. Each of these examples reflects the diverse ways in which socio-technical systems are woven into efforts toward more viable ecological futures.